Hello, I'm JW. This time we're going to have a look at Amendment 1, and by Amendment 1 I mean Amendment 1 to this blue book here, the 18th edition of BS7671. Now, the good news is you don't have to actually go and buy a new book because there isn't one. This is still valid. Amendment 1 is a very small amendment, and it only covers one particular section, which is section 722, and that's the one about electric vehicle charging installations. So virtually everything is unchanged apart from that particular section, and even within there's only some items that have actually changed. So it is a very small item. Now you can actually get this for free from the IET website. Link to that is in the description, and you can download that and read it for free. Now the only restriction there is that if you do download it, you can't actually print it out. It's for viewing on the screen only. And that's what we're going to be using here, as we are going to be viewing it on the screen. If you want to have one you can print out, that is also an option, but you have to pay £5 for that, and then you can print it out and stick it in the book should you want to do so. But either way, the information in it is exactly the same. It's just that can't print it, or maybe you can, restriction there. So have a look at this one. So there's not a huge amount of changes in this. It is literally just that one small part, but nevertheless we'll cover those changes and see what kind of implications that has. Now this is the document here, and as you can see at the top here it's actually got 16 pages. However, don't be put off by that because a lot of the pages are things like the cover and the content and the introduction and all of that. So if we just scroll through here, and you can see it's other one here, not for printing and whatever. And cover there, this is just basically the standard introduction. This is the contents, and bearing in mind a lot of this is just the same stuff as is in the blue book at the moment, so nothing has really changed there. And again the same with that as well. This is just really the summary of the changes here. So again it's section 722, electric vehicle charging installations, and of course there's a minor change there in that definitions, and 700 which is the contents for that, and a couple of minor bits in the index and of course the appendix, but the main point of it is it's section 722 there. Now as in previous versions or amendments, the right hand margin here says a vertical line against various items, and that indicates that the thing has actually changed from the previous version. So anything that doesn't have a line is exactly the same and therefore hasn't changed in any way. So it's only things with a line, and just as in previous amendments and editions, just because the line is there doesn't mean that there's anything of particular relevance has changed. In a lot of cases it is just one word has been changed or some other minor punctuation or something like that. So again, it's not necessarily all of this has changed, it's just indicating that someone put a full stop in where it was missing or something. Now I'll just zoom into the whole width of the page there so we can see it a bit easier, certainly on smaller screens. Now the change here, first of all, is one where they've actually deleted something. So at the moment this ends here where it says charging mobility scooters and similar vehicles. There was actually a note there previously which has been removed, which was requirements of protection for safety when feeding back electricity from an electric vehicle into a private or public supply and network under consideration. That note's gone away, so that's actually no longer applicable. 72311201, which is load curtailment, including load reduction or disconnection, either automatically or manually, may be taken into account when determining maximum demand of the installation or part thereof. Now what this is meaning is that in the previous version it basically stated that you can only have the maximum load current for each charging point and you can't apply diversity or anything like that. But now this is basically indicating that you can buy equipment, as in charging equipment, which can monitor the total load on the installation, and you can actually program in at the installation point how much load is allowed to be taken for the whole installation. So if you program it in, say had a thing which supplied say 4 different vehicles, you could program something to say that the total load in the installation can only be a maximum, say 80 amps or something, and then it has a monitoring device on the supply conductors, and therefore when you plug in one or more vehicles, the total actual load or amount of power that can be provided to those vehicles will be automatically adjusted so that the load on the installation does not go above the set value. So in this case you now can use that to determine the maximum demand because you're basically programming it into the equipment, and that's designed obviously so that it won't ever go above that particular level. This one at the bottom here, 72311221 on TN systems, a circuit supplying charging equipment for electric vehicles shall not include a PEN conductor. This has changed, but it's again the same kind of thing. It's the sentence itself has been rearranged. Previously it just said for a TN system the final circuit supplying a charging point for electric vehicles shall not include a pen conductor. So it's the same thing, it's just been rewritten slightly. And we get into this section here, which is 724114 and specifically 41141, and this is where a fairly significant amount of changes and additions have been made. Now, this particular part applies to a TN system only, as in TNS or TNCS, and specifically this part provides to a PME earthing facility. Generally that's going to be a TNCS system. Now this top bit is essentially the same. A PME earthing facility shall not be used as the means of earthing for the protective conductor contact to a charging point located outdoors, or that might reasonably be expected to use to charge a vehicle outdoors, unless one of the following methods is used. And previously there was 3 of these methods, 2 of which were implausible and impossible, and the other one of which was doable but not particularly useful. The change here is that some of the text has been rewritten, and rather than having 3 items now, we actually have 5, so a couple of new items have been put in there as well. So this only applies to TNCS or PME type facilities, not applicable to TT or TNS type installations. And your choices here are not to use the PME earthing facility. The only choice there is to use it to convert it to a TT installation. And if you are going to use that PME earthing facility, it has to comply with one of these 5 items. So the first one is actually the same. This is where you have a 3-phase installation that also supplies loads other than for electric vehicle charging, and because of the characteristics of the loads in installation, the maximum voltage between the earthing terminal installation and all of that does not exceed 70 volts. So what this means in practice is you've got a 3-phase installation which has balanced loads connected to it 100% of the time. Now this is an incredibly unlikely scenario. It does not apply to domestic installations because virtually no domestic properties have 3-phase supplies, and even the ones that do, it's not going to be a perfectly balanced load all the time. So this hasn't changed, it's still in there, and it's one of the things which really is so impractical and unlikely that really it's not actually going to happen, because, say, a completely balanced 3-phase installation is pretty rare and, say, never going to happen on a domestic anyhow, so not particularly useful. And again, it hasn't really changed. The only thing that has changed here is this note 2, and note 2 basically says the same thing, they've just rearranged it slightly, so it now says when undertaking an addition or alteration to an existing installation, and previously it said when undertaking alterations and additions. So again, it's the same wording, someone's just rearranged it for some personal reason there. So that's pretty much the same, but you're never going to use it because, say, it's such an unlikely scenario that really it's not going to happen. Now, point number 2, this again is the same, although there has been some rearrangement of the wording there. So the main earthing terminal of the installation is connected to an installation of electrode by a protective conductor, and the resistance of this to earth shall be such that the maximum voltage between the main earthing terminal and the earth in the event of a circuit fault on the pen conductor does not exceed 70 volts. So this is where you're putting an earth rod in, or more likely a huge earth mat under the ground, connecting it to the installation earth as well as the incoming pen conductor. And the idea of this is that if the pen conductor goes open circuit and the voltage on it rises, because you've got this substantial earth mat connected to it, that will keep the voltage down as low as possible, and it won't exceed the 70 volts. Again, some rewriting has been done here, but nothing of any particular relevance. Now this is valid, but unfortunately to get this in any kind of useful option, the resistance of that earth electrode has to be incredibly low, and it says there in note 3, then you can actually have a look in the annex there, and it will tell you how you can calculate that. In reality, you're looking at a resistance there in the order of 2 ohms or something like that, which you're simply not going to get with a single electrode or even a whole pile of electrodes in. The only practical application for this would be if you, say, putting one in, say, a domestic environment, the customer is having the entire driveway dug up and replaced, and as part of doing that, they're going to have a big mesh put under the driveway, so the sort of thing like in reinforced concrete or something, and that is going to be used as the electrode. So could be done, but it's not going to be a popular option, suggesting that to have your car charging point installed, you're going to have a whole new driveway installed. But practical option if you're going to have a new driveway, but otherwise not something you're going to be using in most cases. And again, it would apply to other installations as well, but say it was in a car park, in a commercial building, whatever, you would need a huge earthing mat put under the ground, obviously when the car park surface is installed. So if you can get there before the surface is put there, well, that's great. But if not, well, again, it's not going to be practical to start destroying that to put an earth mat in. Number 3 here, this is essentially the same as before. It's this mythical device which disconnects the various conductors within 5 seconds. If you get a voltage greater than 70 volts between the pen conductor, which is essentially the earth terminal of your installation, and the actual earth outside, this would need a reference earth electrode installing, and then it would monitor the voltage between those two and disconnect all of the conductors, including the earth conductor or the protector conductor, if this situation occurs. This doesn't exist. No manufacturer is making it. It's not available to purchase, and therefore, in theory, you could use this, but in practice you can't, simply because the device itself isn't available and doesn't exist, also known as the unicorn device. You'll hear that called by many people. So if somebody cares to make this, and whether it's a separate thing or included in the charging equipment as we got there, then fine, but it doesn't, and there's no indication that it ever will. Now we move on to the 2 here at the end, number 4 and 5. These are entirely new and did not exist previously, so we've got a couple of extra options here. That's pretty good because the previous options are so unlikely and implausible that really nobody was going to use them anyway. Now, number 4, protection against electric shock in a single-phase installation is provided by a device which electrically disconnects the vehicle from the live conductors of supply and from protective earth, in accordance with the regulation in 5 seconds. And it does this disconnection when the voltage between the line and neutral conductors is greater than 253 volts or less than 207 volts. Now, those particular voltages are the standard range for voltages in the UK. That's your 230 volts plus or minus the percentages. And the device shall provide isolation of these selected in accordance with that table. Equivalent means of functionality could be included in the charging equipment, and in fact probably will be. Closing or resetting shall be possible only if the voltage between line and neutral is in the range of 207 to 253. So essentially this is some kind of device which monitors the voltage between the line and neutral conductors at all times. If it goes outside of this range, which is just your normal operating range for voltages, it will disconnect the conductors and the protective earth, and then it remains off until someone turns it on, and you won't be able to turn it on unless the voltage is within that normal operating range. Now, in principle, this is a good idea because generally, if you have a TNCS supply and the pen conductor, that's the combined earth and neutral conductor, is damaged, then what tends to happen is that the voltage between the line and neutral will go outside of this range in the sum of the circumstances. And of course, the most dangerous part of that is that the voltage on what was the earth conductor or the protective conductor actually becomes fairly high in relation to the actual earth itself outside. And of course the problem there is that someone standing on the earth outside with a lead in their hand or touching the car could get a fatal electric shock. Now, there is a problem with this particular item here in that it is possible for a broken pen conductor to occur and the voltage between line and neutral remains within this range, but the voltage between either line and neutral to the actual earth outside is greater than 70 volts. Now, this can happen by having an unbalanced three-phase system, because when you have an unbalanced three-phase system, the neutral point is not actually at the neutral point anymore. It tends to move away, and the voltage on that can actually be higher. And you might think, well, a domestic property or single-phase installation doesn't have any three-phase in it. Well, of course it does, because most domestic properties, although they have single phase in the property, that supply is actually from a three-phase supply in the street, and it's quite often the case that you have a row of houses. Say the phase is connected at one house, the next house has the other phase, and then the third phase in the third house, and then it just repeats like that down the road. So although it's a single phase in the property, the actual supply itself is from a three-phase supply, and because of course it's supplying many different houses, it's always going to be unbalanced because there's absolutely no possibility of those houses all having the exact same load at all times. So depending on the load you have in the various properties next door or across the street or wherever, if the pen conductor is broken, the neutral point is not going to meter anymore. It is going to move in one direction or the other, and some of the properties may have a voltage outside of this range, either too low or too high, and this device would work. But it is possible for at least some of those properties to have the voltage between line and neutral within this range, but crucially the voltage between the true earth outside and those two conductors could be more than 70 volts, which would still result in a dangerous electric shock if someone was, say, standing outside and touching the car or some other exposed metal part. So this is certainly an option to use, and it will be useful in some instances, but crucially not all instances. Now, if you have a three-phase supply to your particular property, so more in the commercial or industrial environment there, then a device that does this is valid in pretty much all circumstances, because the difference there is you can actually monitor the voltage on all three of the phases and the neutral conductor coming in. So therefore, if the voltage goes outside that range on any one of the phases relative to neutral, then it will disconnect all of the phases, the neutral and the protective conductor, and of course that's absolutely fine. But say with a single phase installation, of course, you've only got access to one phase, and if you're unlucky enough to get the one which is remaining within that range relative to the neutral, then of course it's not going to disconnect, even though that could be a dangerous situation. Now, number 5 here, which is by far the most vague item of this, protection against electric shock is provided by use of an alternative device to those in 3 or 4, and that's the one we were just talking about there, which does not result in a lesser degree of safety than using 3 or 4. Equivalent means of functionality could be included in the equipment, and it shall operate by doing the same thing, disconnecting all those conductors on the protective earth, and it shall provide isolation and so on. So essentially this is some sort of cover-all situation for stuff that may not exist yet, and may not be specifically mentioned here. And essentially it's covering the 2 items we had earlier, so it's 3 and 4, the unicorn device, which nobody makes, and then this other device which monitors the voltage between the conductors, which is a thing you can currently buy. So previously there were certain manufacturers of these charging points which have devices which claim to cover what's basically written in here. Previously, when you were actually using those, you couldn't fill on the certificate complies with BS7671 because, of course, it wasn't actually listed here. So you had to put that in as a departure from the regulations, and then you would put in the section on departures. We're using a such and such device from whoever the manufacturer is, and they have stated that this provides this particular feature, safety, and so on. The difference now is you can say, yes, it does comply with BS7671 because of this particular item 5 here, and therefore it's sort of a minor technical change there. And of course, again, with this, you will need to get details from the manufacturer to confirm that it does provide this degree of safety, and it is going to obviously operate in the particular instances given. So not a whole lot has really changed there. All it's done is saying that stuff that existed previously, and of course new stuff may be coming along, previously you had to note it as a departure, stating the manufacturer says this and this and this, and now you can say yes, it does comply, but you're still going to have to mention in there that the manufacturer states that it does in fact comply with this standard, that standard, or whatever else. And the note 5 here, as it says here, BS7671 does not deal with safety requirements for the construction of electrical equipment. Where equipment to be used is not covered by a British or harmonised standard, or to be used outside the scope, it's the responsibility of the electrical installation designer or other person responsible for specifying the installation to establish that the manufacturer of the equipment has ensured that the equipment satisfies the safety objectives of the relevant directives, as it would not benefit from a presumption of conformity afforded by the appropriate product standard. So in other words, you still need to get some kind of evidence from the manufacturer to confirm that their device or mechanism or whatever they've made does provide the appropriate degree of safety when it's installed in these circumstances with a TNCS supply. But at least this does give the option there to install things which say either are new on the market or say don't even exist yet and will be available in the future. Say that, yeah, provided manufacturers saying that it covers whatever, then you can install it and it will comply with BS7671. This piece at the bottom here, where buried in the ground, protective conductor and so on, yes, it has changed, but again, it's one of these minor piffling annoyances where they've actually just changed a couple of words in it. This particular one now says connected. Previously it said connecting, so yes, that's really worth it, isn't it? Now on the next page here we've got this piece here, and this is essentially all new, including this note 6 here. We've also got some new notes up there, so that was 5, obviously that's new as well, so continuing on from that section, but all of this is new. So protective conductors and exposed conductive parts downstream of a protective device provided for the purposes of 3, 4 and 5, and bearing in mind those are the new ones plus the unicorn device, shall have no connection to any protective conductors or exposed conductive parts of any circuit not protected by the same protective device, or any extraneous conductive part. So essentially this means that anything that's connected downstream of that device mentioned in 3, 4 or 5 will not be connected in any way to any of those items we've got there. So no exposed conductive parts and no extraneous conductive parts, and pretty much anything else that's basically conductive, as that covers both types there. Now this isn't going to be particularly difficult to do because in most cases the devices mentioned are going to be integrated into the charging point. So you just have the charging box on the wall, and that's where the device is, and all it's covering is literally the charging lead coming out that you would plug into the vehicle. But there might be some really vague things where if you've got, say, the thing rather than the charging equipment, it was in the building somewhere, you can't have any connections between anything from that point onwards to any other circuits or exposed conductive parts or whatever. So things like supplementary bonding from the protective conductor there to, say, a nearby water pipe is not permitted because that's obviously a connection to some other conductive part there. Not particularly likely, but it has been mentioned there. Note 6 is of particular importance here. Creating a TT earthing system for charging equipment or the whole installation as an alternative to using a PME earthing facility with one of the methods above may not be an appropriate solution. Now, this is where you've got the TNCS or PME supply, and rather than going through all those things we just mentioned, you can simply not bother to use the PME terminal whatsoever, just not connect to it at all, install your own electrode or electrodes in the ground, and then make it a TT installation. Now this is not necessarily appropriate because due to the inability to provide sufficient separation from bone metalwork connected to the supply pen conductor. This video is not particularly on TT installations, but a key point about installing earth electrodes is that when you install them, they need to be as far away as possible from anything else in the ground, which they could be connected to an alternative earthing system. So if you're going to put an electrode in, you need to be a decent distance away from things like buried electrical cables, buried metal water pipes or gas pipes, in fact any other metallic item that's actually under the ground there, because if you, say, had a cable coming to a property, it's going to have main bonding to the gas and water supplies, and if the gas pipe, say, was metallic, which a fair number of them still are, and that was going under the driveway, if you put in an earth electrode and it's, say, half a metre away from that gas pipe buried under the ground, when a fault occurs, the pen conductor voltage will rise above the normal ground, and because you've got that metal conductor under the ground, and it's only, say, half a metre from your actual electrode, some of that voltage is going to show up on that electrode you've put in, and of course that's going to completely ruin the whole point of having it in the first place, because then all the stuff connected to that is again going to have that dangerous voltage on it. And the same applies to putting it where, say, near electric cables in the ground, because certainly, again, it's too close to existing electrical equipment. So water pipes, gas pipes, incoming supply cables, and pretty much any other electrical or metal items that are in the ground that are connected to the installation in some way. Now, how far away it has to be does seem to vary. If you're going to put an electrode in, generally the rule was that the length of the electrode is the absolute minimum distance between it and something else, multiplied by 2. So if you had, say, a 1 metre depth electrode, you need it at least 2 metres away from any other items within the ground. Some network operators have specified things like 5 metres away as an absolute minimum, and this is already into the realms of big problems, because if you've got, say, the driveway in the front of a house, you can't realistically put an electrode in there and then say it's 5 metres away from all the incoming pipes, cables and whatever else, because 5 metres isn't exactly going to put you in next door's garden, and of course you can't go next door's garden anyway because they've got gas pipes and water pipes and all the other stuff as well. So although in the past a lot of people have changed these things just to TT earthing and thought all is well, it all depends on where that electrode is going. You can't put it in anywhere near any existing stuff buried underground, and of course that's assuming you even know where things like gas pipes or whatever are buried underground, because that information may not be readily available. So rather than solving a whole load of problems, this really introduces even more. So as previously, just shove in the old electrode and make it TT, not actually such a good idea, because you can't really rely on it being as far away from those other things under the ground as it should be. Now, the most of what this here hasn't actually changed particularly. There's a couple of notes here which have been revised somewhat. This note here just says an example of the arrangement for a Class 1 electric vehicle from a separated source. It's shown there. Electrical separation isn't, again, a very likely one because it needs to be supplied, it says there, through a fixed isolating transformer. Entirely possible, but that is going to massively increase the cost of the installation, because an isolating transformer suitable to supply an electric charge point even at, say, 7 kilowatts or so, that is a huge piece of equipment. It's going to be extremely expensive, and of course if you're going to have more than one charging point, you're going to have an even bigger transformer, and you're going to have one per point and so on. So just a note there of a possible arrangement in the annex there. A couple of changes here to external influences. Nothing has really changed here, it's just, again, a minor wording change. Previously this related to AD4 and AE3, but again the actual concept of it is basically the same as previously. It was still IP4X, and it still is. It's just deleted the part about the other codes there of AE3 and AD4. Likewise here again, some very minor changes. They've just removed the couple of items there. This is now AG3, previously AG2, so some changes there, but nothing desperately significant there. Now this bit here with the big vertical line, this has changed. Basically some numbers here have been removed. It used to be 725312, that has all gone, and now it's 725313. So we've got RCD shall disconnect all live conductors, so that's line and neutral. Of course live covers line and neutral now, and has done for quite some time. And then we've got unless supplied by a circuit using a protector measure electrical separation, which in other words is that big isolating transformer that needs a crane to hoist it into the building. Each charging point incorporating a toggle outlet or vehicle connector complying with that series shall be protected by an RCD having a rated residual operating current not exceeding 30 milliamps. That's pretty much what it said before, but again it's just been rewritten a bit and it now has a new number. This part here is essentially the same, again with a new number. The main difference here is that we've now got type F added in here, so the type B was already there, the type A was there, so now we've got OR type F in conjunction with the residual direct current detecting device and the relevant standards and so on. So the type F one is that deals with the higher frequency currents there, rather than just the standard type A, which only deals with, of course, 50 Hertz. And this RDCDD, which is basically, as it says there, residual direct current detecting device. Previously that was just called appropriate equipment that provides disconnection of the supply in the case of DC fault current above 6 milliamps. So again, it's the same thing, it's just got its now official name added in there. Just before this here, there's a piece that's been removed, and that was isolation switching, which basically was a single part about emergency switching off. That's now been removed, so obviously no longer applicable. And we've got a note here about vehicle manufacturer instructions should be taken into account when determining the type of socket outlet to be installed, because although there's supposed to be one standard for all vehicles, well guess what, some manufacturers use different ones. So again, pretty straightforward stuff there. That was actually in there before, but again it's one of these that's been minor adjustment there, so nothing has really changed. It now says should be taken into account, and previously it said should be followed. So followed basically means you will comply, and taken into account means, well, you should certainly consider it, but if the manufacturer instructions turn out to be a load of nonsense, then not necessarily to actually continue following them to every detail. But in reality, if a vehicle has a particular type of connector, then of course you're going to be installing the charge point appropriate to that vehicle, certainly if it's one that's going to be used, say, in a domestic environment where you know what kind of vehicle it's going to be. This one here about portable socket outlets should not be used. It's the same thing. It now just says tethered vehicle connectors are permitted. Previously, tethered vehicle connectors are allowed. So again, it's just somebody deciding that they're going to make changes for the sake of it. Really don't know why people would bother, because it's exactly the same meaning, just a different word for the same thing. Now the section here between 1014 and 1016, which of course was 1015, has been deleted for some reason. And why it's been deleted is not clear. What it used to say is that the lowest part of any socket outlet should be placed at a height of 0.5 to 1.5 metres from the ground. So and now apparently you can put them anywhere you want. So you can put them on the floor, on the ceiling, or wherever else. But of course, in reality, it's going to be fixed at a sensible height. You don't really want it below 0.5 metre because it's going to get damaged and kicked in and whatever. And there's also the possibility if there's some flooding, it could be underwater. And obviously, fitting it greater than 1.5 metres from the ground means that no one will be able to reach it. So again, not particularly useful. Not clear why that's been removed, but that's what it said. But really, the concept of it is not changed. This is a new one here, 72555172. The socket outlet or vehicle connector shall comply with BS7671 series. So again, that's not really anything surprising there. It's just been added in as a specific word. So that is all of the changes there. So a lot of it's very minor and irrelevant, but just words altered. But the sort of meat of it is back up here with those now 5 things you can use if it's a PME earthing facility. And the most important ones are in fact the ones that have been added, because the other 3 are pretty much the same and very unlikely to be used. So it's protection against shock by the device monitoring the voltage between the line and neutral conductors, so between 253 and 207, and some other device or devices which may or may not exist, and if they do, then they can't provide any less safety than the item in number 4, or in number 3, the unicorn device, which of course does not exist. Now, Annex A72, there are minor changes here, but again, nothing particularly of use here. It's just, again, some minor adjustments to some of the items within here. This is just guidance for TN systems where PME conditions apply. Calculating the neutral current of a 3-phase installation, load balance, earth electrode resistance, and so on. And of course, you can do all these calculations if you want to, but if you do this calculation here, you're looking for an earth electrode. That's where you're connecting it to the PME terminal and having your electrode as well. It comes out in the region of sort of 2 or 3 ohms or something in most cases, which I say is incredibly low. So, bit of an adjustment here. This used to be a section here on symbols used, so they've added this piece in on voltage monitoring device, and this again refers to this unicorn device which doesn't exist, so it's monitoring the voltage between the circuit protective conductor and the earth itself, meaning there's got to be a reference earth electrode. Bit of information about there how it could actually work, but again this doesn't exist, so until it does, not a whole lot of point in going in there. We've got an interesting bit here about where used. Measurement earth electrodes should be located at sufficient distance from other earth electrodes and other buried exposed conductive parts and extraneous conductive parts. As I said earlier, if it's not, and a fault occurs, then that voltage can be transferred onto the electrode, which completely negates the point of having it. As it's got down here, it's recommended the minimum separation distance is 2 meters, and that would be, if you say a more traditional earth electrode of say 1 meter depth, it would need to be 2 meters away, say twice the distance. But up here we've got clauses from a different standard, BS7430. A separation distance of at least 8 meters reduces the voltage transfer from the PME earthing system to less than 20%. So again, 8 meters away from any buried conductive items like metal pipes or cables or whatever, certainly in a domestic environment that is going to be pretty much impossible because a lot of houses aren't even as wide as 8 meters. So yeah, that's why it's just converting it to TT is often not going to be a particularly practical option. And say a bit of additional information there taken from that additional standard BS7430. The rest of this is pretty much as before, just some examples of a separated system there. And then we have the appendix 1, which again existed previously. Some of these have been updated here because of course some of the numbers here have obviously changed. It's just a list of other standards which refer to various things within there. And finally then just the index. Again, some of these have obviously altered because some of these numbers have changed, so just a little revision to the parts of the index as applicable. And that is the end of that. So that's Amendment 1, and just repeat the piece there about the caution in that particular new item they've added in there about the voltage monitoring. Voltage monitoring alone between the line and neutral conductors is not sufficient to detect all cases of a broken PEN conductor, because it is perfectly possible for the PEN conductor to be broken and the voltage on both the line and neutral to rise. So the difference between those can still be within the actual agreed limits there. But of course the difference between those and the actual ground or the earth outside where someone is going to be standing can still be greater than 70 volts and therefore give people dangerous or even fatal electric shock. So although that's actually in there, that is only part of a solution because, as I say, in many cases if the PEN conductor is broken it will cause that voltage to go outside of the range, either too high or too low, but certainly not in all of them because again it's that unbalanced 3-phase system, the other 2 phases being your neighbours' houses. Of course you have no control over what kind of loads and things are going to be connected in there. So it may well be an improvement in the right direction, but it is certainly not some kind of final fixes-all solution at all. Other considerations certainly need to be taken into account there. So that's it for this video. Until next time, thanks for watching.